We are going to look at standard graphs. The first standard graph being the graph of y is equal to 1 over x. This graph doesn't touch both x and y axes like this, doesn't touch the axis, We say it is asymptotic to both x and y axes. The next graph is the graph of y is equal to x. This one is symmetric about the axis, passes through the origin, and every y coordinate is equal to every x coordinate. Y is equal to x squared. This one is touching the origin and it is symmetric about the y-axis. What we see on the right-hand side is the same as what we see on the left-hand side. Y is equal to x cubed, passes through the origin, and this part right here is a mirror image of that part as well. Trigonometric graphs, y is equal to sine x, drawn at 90-degree intervals. And this graph ranges from -1 to 1. Sine of 0 is a 0. Sine of 90, that's a 1. Sine of 180, that's a 0 again. Sine of 270, that's a -1. Sine of 360, we're back to 0. Sine of 450, that's a 1. So there's a cycle 0, 1, 0, minus 1, 0, 1, 0, minus 1. So no need to calculate. -1, 0, and a 1. That's the pattern. We join. That's the graph for sine x. Next graph, we want to look at the graph of cos x. Same range with sine, but this time the pattern starts from 1, 0, -1, 0. 1, 0, -1, 0, and we join. So that's the graph for the cosine of x. Y is equal to tan x, drawn at 90-degree intervals, but this time ranging from -infinity to +infinity. Tan of 90 is infinity, so what we have are asymptotes at 90 degrees. So there is your asymptote. Now, these asymptotes occur after every 180 degrees. So we're going to see them at 270. We are going to see them at 450. We are going to see them back 180 degrees from 90. That's at -90. We shall also see another asymptote at -270. The graph won't touch those asymptotes. So we draw it from asymptote, passing through the x-axis towards another asymptote, avoiding touching the asymptotes. Same thing in other parts of the graph. So in the end, it looks like this. You can pause and watch. Transformation. Y is equal to f of x plus a. This one is a translation in the y-axis. 0 and a positive a in the y-axis. Take note, the positive a is outside the bracket. That's what distinguishes it as a y-axis translation or movement. So what you do is you are adding a to y coordinates. If it's a negative, you are subtracting as well. So effectively, that's adding a negative a to all y coordinates. Translation involves movement. So if it's a positive sign, it means your graph is moving upwards along the y-axis. If it's a negative sign, your graph is being dragged downwards along the y-axis vertically. Y is equal to f of x plus a. This time the positive a is inside the bracket, which implies this is a translation, but it's in the x-axis this time, and it's a translation of a negative. The sign changes there. So it's a translation of a negative a in the x-axis and 0 in the y. So what you do is you are adding a negative a to all x coordinates. And in the event that we have a negative sign there, it turns to positive. We are now adding a positive a to all x coordinates. We are moving the graph along the x-axis. So if we have a positive sign, that implies negative movement. So our graph is being dragged to the left-hand side along the x-axis. If it's a negative, our graph is being dragged to the right-hand side along the x-axis. F of ax is the next transformation. That's a stretch. And its factor now is 1 over a. In the x-axis, you are dividing all x coordinates by a, or you are just multiplying by 1 over a. So that's a stretch x-axis invariant. A f of x is the next transformation. That's another stretch, but this time it's in the y-axis invariant. And its factor is an a. So you multiply all y coordinates by a to stretch your graph that much. F of negative x, this one is a reflection in the y-axis. And you multiply all y coordinates, or x coordinates rather, by a negative. So they move, what's on the right will go to the left and vice versa. Negative f of x is our next transformation. That's a reflection in the x-axis. You multiply all y coordinates by a negative. What's below the x-axis will go above, and what's above will go below the x-axis. The graph of y is equal to f of x is transformed to the graph of y is equal to 1 plus f of half x. Describe fully these two single transformations which have been combined. So the first transformation I'm seeing is an f of half of x, and according to the notes, that's a stretch in the x-axis, and the factor is a factor of 2, because the factor is always 1 over the coefficient of x. So 1 over half, that's where we have the factor of 2. The second transformation is 1 plus f of x. That's a translation in the y-axis. So it's a translation of 0x and positive 1 y-axis. The next question. In the diagram, the graph of y is equal to f of x is shown with solid lines. The graph with broken lines is a transformation of y is equal to f of x. Describe fully the two single transformations of y is equal to f of x that have been combined to give the resultant transformation. So for this kind of questions, the first thing you need to check before describing is the size of your graph. So you need to check if the size of your graph has changed in terms of the y. You check vertically, right? So this graph has been covering just a single box, the original graph. So we check the size now vertically for the resultant graph. It is now covering a total of 3 boxes. So there's been a change in the size, which means we have a stretch of a factor of 3. We have multiplied a distance of 1 to become a distance of 3. So there's a stretch of factor 3 in y-axis invariant. So that's our first transformation for this graph. This stretch multiplies y coordinates by 3. Y coordinate of 1 gave us a 3. Y coordinate of 2 gave us a 6. So a stretch would always multiply y coordinates by the factor. Now we check the size in terms of x. It's covering 0 to 2, and it's also covering 4 to 6 on the image. So nothing changes for the size in terms of x. So what has changed the x coordinates? That's a translation. It's only a movement. So it's a translation of, we've moved to the right hand side, so it's a positive. How many boxes now? If we moved, we check 2 corresponding points to know we have a point of 4 here, which was originally a 0. So we have moved positive 4, 0. There is no movement in terms of y. Remember, y coordinates changed as a result of multiplication. Now on part B of the question, state in terms of y, f, and x the equation of the graph shown with broken lines. We are going to use the transformations, the two transformations that we discussed in part A to come up with the equation. So the first one was a stretch. It's in the form af of x. And the second one was a translation positive x, that's f of x minus k. So our equation would be y is equal to 3 f of x minus 4. Next question.
In the diagram, the lower curve has equation y is equal to cos theta. The upper curve shows the result of applying a combination of transformations to y is equal to cos theta. So find, in terms of cosine function, the equation of the upper curve.
So we shall come up with the equation based on the transformations that have happened. So to check for the transformations, we start by checking the size in terms of y and the size in terms of x. That's the first step to identifying the transformations. So let us check our graph vertically to see if there is any change in size. So this one is covering about 2 boxes, the original graph. And how big now is the image? It's now covering a total of 4 boxes. So a space of 2 has changed to a space of 4. So this change in size vertically from 2 to 4 implies that we have stretched our graph 2 times. So there is a stretch of factor 2 to y-axis invariant. So that's our first transformation that we shall use to come up with the equation of the image. Now that we have a stretch of factor 2 in the y-axis, that means we've multiplied our y-coordinates by 2. So we need to just verify if indeed that's what has happened. So we're going to take a look at our original point, -1. If we multiply that by 2, that's supposed to give us a -2. If we multiply this point 1 by 2, we are supposed to get 2. So if we had just stretched in terms of y, we're supposed to be having these coordinates. But now if we take a look at our image graph, it's not giving us that exactly. Our image graph is the points 1 and 5 instead of the -2 and 2, right? So that means probably we had a translation that moved these points. So we were supposed to be having -2 and 2, but now we have a 1 and the other point being a 5. So what changed a -2 to become a 1? It's a translation. It has been shifted upwards. By how many steps now? -2 up to 1, there's a distance of a positive 3. Because you could just subtract 1 minus -2. So we translated this stretched graph by a +3. You could even check the same thing with this 2 that we were supposed to have as our upper limit of the graph after stretching. It became a +5. 2 to 5, that's a +3. So yes, our second transformation that we are noticing is a translation of +3 in the y-axis. So let's keep checking the size now in terms of x. This space here from 0 to 2 pi is now occupying a space of 0 to 4 pi, right? So that means we have a stretch in the x-axis of factor 2. These are the transformations that changed our graph. So now let's come up with the equation. The stretch of factor 2, that's a 2f of x. Then the translation in the y-axis of +3, that's f of x plus 3. Then the stretch of factor 2 in the x-axis is f of half x. So now our equation would become 2 cos half theta plus 3 using those transformations. These are now some practice questions that I would want you to try. So you can pause the video, copy the questions. You try those to test your knowledge. If you need any assistance, of course, you can contact me. We assist each other as to how you do this transformation. So pause the video, screenshot the questions, do the questions, and see if you can get them right. The next question, the function f is defined by f of x is ax plus b, where x is an element of real numbers. And of course, a and b are constants. It is given that f of 2 is equal to 1 and the function of 5 is equal to 7. Find the values of a and b. f of x is ax plus b. So for f of 2 is equal to 1, we substitute x is equal to 2 and we equate to 1. So it becomes a by 2 plus b is equal to 1, which gives us an equation 2a plus b is equal to 1. So that's simultaneous equation number 1. Then f of 5 is equal to 7. We substitute x is 5 and we equate to 7. So a by 5 plus b is equal to 7. 5a plus b is equal to 7. Then we solve the two equations simultaneously. We are going to subtract these two equations, method of elimination. So when we subtract, what happens? We are going to have 2a minus 5a. So 2a minus 5a will give us negative 3a. Then b subtract b, that's going to give us a 0. Then 1 subtract 7 will give us a negative 6. So our a is a 2. Substitute your a is 2 back into any of the two equations. That's supposed to give us our value of b being equal to negative 3. Part 2, solve the equation f of x is equal to 0. That's a composite function. We are going to substitute the function of x in place of x. So our function of x now is now 2x minus 3 based on the values of a and b that we got. So a composite function, we take the front function, we substitute it into the back function f. So f of x will be substituted into the function f. In place of x right there, we are going to substitute the whole function of x in place of x. So let's do that now and see how it's going to come out. So this is going to become 2. Then in place of x, we substitute the whole function, which is 2x minus 3 that I've put in red. Then subtract 3 is equal to 0. So then we solve our equation for x. We expand the brackets. 4x minus 6 minus 3 is equal to 0. So x is 9 over 4. Next question. The functions f and g are defined by f of x is equal to 3x plus 2, where x is an element of real numbers. G of x is 6 over 2x plus 3, where x is an element of real numbers and x is not equal to negative 1.5. Find the value of x for which f of gx is equal to 3. So that's for 3 marks. F of gx is equal to 3 is a composite function where we'll take g and we'll substitute it into f in place of x. So I'm going to write out my f, 3x plus 2, and I'll equate to 3. And in place of x now, in red, I'm going to substitute my g. My g is a 6 over 2x plus 3. So now we solve the equation, multiply 3 by 6, that's 18 over 2x plus 3. We equate to 1 because 2 has gone there to be subtracted. So 18 is now equal to 2x plus 3, therefore x is 15 over 2. Part 2, sketch in a single diagram the graphs of y is equal to f of x and the graph of y is equal to f inverse of x, making clear the relationship between the two graphs. So my f of x is 3x plus 2. That's a straight line. That's going to be easy to draw. No need for transformations. So when x is 0, y is a 2. Then when y is 0, x is a negative 2 over 3. Like that. So it's a straight line. That's my function of x. Now I also need the inverse. The graph of y is equal to f inverse of x is a reflection of the graph of f of x in the line y is equal to x. So it's a reflection in the line y is equal to x. So I'll first put my mirror line in blue. That's my line y is equal to x. So I'll reflect. The y coordinate will become the x coordinate. The x coordinate will become the y coordinate. So y coordinate of 2 becomes an x coordinate of 2. X coordinate of negative 2/3 becomes a y coordinate of negative 2/3. So that's where my f inverse shall pass through. So let me draw my f inverse, different color now. This is going to be my inverse graph. So that means I've reflected My mirror line is y is equal to x. My f inverse of x is drawn there. Part 3. Express each of f inverse of x and g inverse of x in terms of x and solve the equation f inverse of x is equal to g inverse of x. We are going to get the inverse of our function of x being 3x plus 2. So to get your inverse, you are going to equate your function to y and you make x the subject. So x is equal to y minus 2 over 3. Then to write your f inverse now, you replace your y with x. So it's f inverse of x is x minus 2 over 3. We do the same thing for g of x. We want to find the inverse of g of x. So I equate my g of x 6 over 2x plus 3 to y. I then make y the x the subject of the formula. So cross multiply 2xy plus 3y is 6. 2xy is now 6 minus 3y. Divide both sides by 2y. So my x is that. Now I replace y with x's. So my g inverse is 6 minus 3x over 2x. The equation we want to solve is f inverse of x is equal to g inverse of x. So I'll write my f inverse of x on the left-hand side, my g inverse of x on the right-hand side. I'll cross multiply both sides and I'll get a quadratic 2x squared minus 4x is equal to 18 minus 9x. Then I solve my quadratic. You can use factorization. So my value of x is negative 9 over 2 or 2. Number 6, sketch the graph of the curve y is equal to 3 sine x for x is between negative pi and positive pi. So this is drawn at 90-degree intervals, but in this case it's in radians, so it's at pi over 2 intervals. So this graph is a stretch of factor 3 in the y-axis. So all y coordinates have been multiplied by 3. We now have negative 3 and 3. So let us plot the points. Our graph would be a pattern of 0, 3, 0, negative 3, 0, 3, 0, negative 3 from our knowledge of the sine graph, which was going 0, 1, 0, negative 1. So let's join our points like that. There is our graph. Alternatively, this is a graph that you may have used just your calculator, punching in the values of x and getting the respective y coordinates, and you would still plot the graph of 3 sine x. Next part, the straight line y is equal to kx, where k is a constant, passes through the maximum point of this curve for x is negative pi up to pi. Find the value of k in terms of pi, 2 marks. Our equation is y is equal to kx, and it passes through a maximum point, the coordinates, which are pi over 2 and 3. So we just substitute y is 3 and x is pi over 2. So we solve, we divide both sides by pi over 2. Our k is 6 over pi. Part 3, state the coordinates of the other point apart from the origin where the line and the curve intersect. So this is a straight line y is equal to kx passing through the origin and through pi over 2, 3. So if we are to draw a line from our sketch, that would mean it also passes through the minimum point. So the other point would be negative pi over 2 and negative 3. Next question. The function f, where f of x is a sine x plus b, is defined within the domain x is between 0 and 2 pi. Given that f of pi over 2 is 2 and f of 3 pi over 2 is a negative 8, find the values of a and b. F of pi over 2 is equal to 2. I substitute pi over 2 for x. That will be a sine pi over 2 plus a b, and I will equate that to 2. Now, sine of pi over 2 is a 1. You do that with your calculator in radians. So this becomes a plus b is equal to 2. That's my equation number 1. Now, f of 3 pi over 2 is equal to negative 8. I will substitute 3 pi over 2 in place of x and I will equate to negative 8. Sine of 3 pi over 2 is a negative 1. So this becomes minus a plus b is equal to negative 8. My equation number 2. I now solve the equations simultaneously. I'll subtract the two equations and that would give me my b is equal to negative 3 and my a would be a 5. Part 2, find the values of x for which f of x is equal to 0, giving your answers in radians correct to 2 decimal places. So I would want you to do that part 2, together with part 3 as well. Pause the video, screenshot, and try those questions so that we see if your understanding is improving for your functions. You can also try this question as well. Pause the video, take screenshot or image, and attempt this question as well. Finally, you can also do this question as well. And remember to contact us for more worksheets on functions.